Hi, welcome to my attempt to gamify coding interviews. So this video is going to be about what you would expect. I'm going to show you a bunch of interview questions that have historically been asked in FAANG coding interviews, and there'll be a variety of difficulties ranging from LeetCode easy to hard. But the questions themselves are not ordered by difficulty. And for each question, your job is to guess the main algorithm or data structure used to solve the question. You don't need to work out the details, all you need is the required topic. There won't be too many questions that require multiple topics, but I will throw in a couple to keep it interesting. And so here's how this video will be structured. There will be 25 questions in total. For each question, I'll show you the question itself and read you a short version of each statement. Then I'll give you a bit of time to figure it out with just that, and then if you're stuck, I'll list out a few random topics with the answer being one of the choices, or a subset if there are multiple required topics. So multiple choice, basically. But feel free to try to figure it out without these hints. And then finally, after that, I'll tell you the answer with both the required topics and then a brief overview of the solution to show how those topics are applied. You're encouraged to pause throughout each question to spend time to figure stuff out for yourself. And if you don't know some of the random topics, I'll put a dictionary in the description. I'll also put the question list in the description. And feel free to try each one, and feel free to use this video as a hint system, and feel free to comment how many you got right or any alternate solutions I missed. Also, feel free to comment and ask me to elaborate on any one of my solutions, because I'm going to try to keep them short for the sake of the video length. I did code each question and got accepted for all of them, so you can rest assured that my solutions won't be wrong, though I can't guarantee that I thought of every possible solution, so there may be some alternate solutions with different required topics that I don't mention. So you may be correct even if I didn't mention the solution you thought of. Alright, and now I'm going to talk for a bit about why I think this video is useful and how you can use it to benefit your practice. If you want to skip this, check out the timestamps in the description, or you can just jump to the first question. So, a simple way to use this video would be a quick review for an upcoming interview. This is basically as compact as problem solving can get. You're just looking for surface level ideas and not worrying about the details, so it's great for a review. And another is for building intuition. Intuition makes up the first ideas you get for a question, which are often the most important ideas that will take up most of your time in an interview. So you want your intuition to be as strong and accurate, and this type of topic-focused problem solving will challenge your intuition since you don't have the ability to write code and flesh out your ideas, so your first ideas have to be correct. And a similar benefit from this kind of practice is being able to think at a high level. You don't have to work out all the details, and you shouldn't. All you need is a brief description of the topics you're going to use and how you're going to use them. And this skill of thinking at a high level can be very useful for expressing your thought process in an interview, since you're able to easily understand and explain the big picture ideas of your solution. You can also get better at pattern recognition for the relevant topics. For any particular topic, there's two things you need to know for it to be useful: how to apply it and where to apply it. And you can learn how to apply it as you learn the topic and use it in some practice questions, but this video's type of practice is especially focused on where to apply the topic. Since for each topic, you'll get a few questions where it does apply and also where it doesn't apply, which are equally important. And finally, if you want to completely try out the questions for yourself, you can use this video as a hint system. There are 3 progressive levels of hints: the list of random topics, the exact list of required topics, and the short overview of the solution and how to apply those topics. So those can help you out with your practice if you'd like. And that's all I can think of, but there's probably more. But yeah, enough from me. Let's get into the actual video. Alright, question 1. Here's the original question. The full details are in the description if you'd like. And here's my short version. There are n people in a line. In order, each person will pay for a $5 lemonade with either a $5, $10, or $20 bill. You should determine if it's possible to give everyone the correct change or not. And note that you can use the bills they give you to give out change in the future. So if you get a 5, you can give out a 5 later. Feel free to pause and think about this. Now, here are your options for the answer. There's brute force, greedy, binary search, and dynamic programming. Again, feel free to pause and think about this. Alright, so the answer is greedy. And the full solution is simple. If you're given a 5, then you don't have to give out any change. If you're given a 10, then you have to give out a 5. But if you're given a 20, you can either give 3 5s or a 5 and a 10. But the choice here is simple. It's always better to have 2 5s over a 10, because 2 5s gives you more freedom in the change you can give. So you should always try to give out the 10 first above the 5s. So we can just simulate and greedily give out the largest change possible and just see if it works. Alright, question 2. Here's the original question. And here's my short version. You're given a 2D grid of letters. For every column that isn't in sorted order alphabetically, remove it and answer with the number of columns you removed. Feel free to pause and think about this. Now, here are your options for the answer. There's greedy, brute force, combinatorics, and 2 pointers. Again, feel free to pause. Alright, so the answer is, I would say both greedy and brute force are fair. You can greedily remove a column and not have it affect any of the other columns, and brute force is because the solution is just check each column and remove the ones that aren't sorted. Calling it greedy is kinda iffy, but I think it's fair since it still fits making the immediately best choice. Alright, question 3. Here's the original question. And here's my short version. You're given a list of numbers. In one move, you should pick a number and flip that number from negative to positive or vice versa. You must perform exactly k moves. Your goal is to maximize the sum of the numbers after your moves and output that sum. Feel free to pause and think. Now here are your options for the answer. There's dynamic programming, hash map, greedy, and brute force. Again, feel free to pause. Alright, so the answer is ultimately greedy. If you have a negative number, you should flip the negative with the largest magnitude or just the smallest value to get the most out of your flip. And if there's no negative number, you should also flip the number with the smallest value to do the least damage to your sum. So ultimately, you should always greedily flip the number with the smallest value. Alright, question 4. Here's the original question. And here's my short version. You're given a 2D grid of 1s and 0s, where 1 is land and 0 is water. The land forms islands that are connected in the 4 cardinal directions. Your task is to count the number of islands. Feel free to pause and think. Now, here are your options for the answer. There's BFS or DFS, Dijkstra, minimum spanning tree, and dynamic programming. Feel free to pause again. Alright, so the answer is BFS and or DFS. You should run a BFS or DFS for each cell and mark all the cells as visited on each cell's island so you don't count any island more than once. But otherwise, it's just straightforward, basic flood fill, BFS, DFS stuff. Alright, question 5. Here's the original question. And here's my short version. Count the number of strings that are length n that are sorted and only have vowels. Feel free to pause. Now here are your options for the answer. There's brute force, dynamic programming, combinatorics, and binary search. Feel free to pause and think. Alright, so the answer is everything but binary search, actually. As it turns out, the answer for the largest value of n is only around 300,000, so brute force would probably work. Dynamic programming is straightforward, the state is the length and previous character. And for combinatorics, the answer is n plus 4 choose 4. I encourage you to ask me about that one. Alright, question 6, here's the original question. And here's my short version. You have a truck. You also have some boxes where each box carries some number of apples. The truck can only hold a certain amount of boxes, so find out the maximum amount of apples that can be carried on the truck. Feel free to pause. Now here are your options for the answer. There's greedy, brute force, 2 pointers, and binary search. Again, feel free to pause. Alright, so the answer is greedy. Since each box contributes exactly 1 box to the truck's capacity, it's always better to just take the boxes with more apples. So you just always greedily take the remaining box with the most apples until you're out of either space or boxes. Alright, question 7, here's the original question. And here's my short version. You have n coins and you want to build a staircase from top down. The first level has 1 coin, the second level has 2 coins, etc. And every level but the last must be completely filled in with coins. So find out the size of the staircase you can build. Now, here are your options for the answer. There's dynamic programming, combinatorics, brute force, or binary search. Alright, so the answer is either brute force or binary search. If you have a staircase with k levels, the amount of coins you'll use is up to k times k plus 1 over 2, which is O of k squared, meaning that k will be around square root n, which is small enough to brute force the size of the staircase. But you can also do binary search on the size of the staircase for a more efficient solution. Alright, question 8, here's the original question. And here's my short version. You have a tree and some of the nodes have apples. You start at the root and it takes 1 second to walk down an edge. Find the minimum time it would take to collect all the apples and come back to the root. Feel free to pause. Now here are your options for the answer. There's BFS or DFS, Dijkstra, dynamic programming, and brute force. Again, feel free to pause. Alright, so the answer is you must combine BFS, DFS, and dynamic programming. Probably the simplest way to approach this is to notice that we'll use each edge either not at all or exactly twice, once going down and once coming back up, since we do have to return to the root. So let's figure out for each edge if we need to use this. And ultimately we can do this using TreeDP. If we're at some node and we know there's an apple in one of its children or that child's subtree, we have to go to that child and take that edge since there's an apple there. And we can figure out if there's an apple in a subtree with BFS, DFS, and TreeDP. and then you just sum up the answers for each edge. Alright, question 9, here's the original question, and here's my short version. You're given an m×3 grid. You want to find the number of ways to paint each cell in one of 3 colors so that no 2 adjacent cells have the same color. Feel free to pause. Now here are your options for the answer. There's binary search, combinatorics, dynamic programming, and 2 pointers. Again, feel free to pause. Alright, so the answer is dynamic programming, and maybe combinatorics. I don't know of any solution that uses it, but if you can get accepted, a point for you then. So the trick is 3 is small. So we can do DP, or the state is the entire previous row, and just iterate through the colors of our current row and just see if the 2 rows are compatible. We can also do some counting tricks where you classify each row as having either 2 or 3 different colors and doing math with it. It's still DP, it's just better because there are fewer states. I wouldn't really call it combinatorics, but you can if you want. And as a bonus, you can also use matrices to speed up this question by a lot. Okay, question 10, here's the original question. And here's my short version. You're given a number x, your task is to find square root x rounded down without using any built-in library functions. Feel free to pause. Now here are your options for the answer. There's binary search, hash set, 2 pointers, and brute force. Again, feel free to pause. Alright, so the answer is either binary search or brute force. Brute force works because you only need to iterate up to square root x, which is small enough to iterate to. And binary search also works though, and it's much faster. Alright, question 11, here's the original question. And here's my short version. You're given a list of numbers. In one move, you can pick a number x and remove all the occurrences of x from the list. You want to find the minimum number of moves to remove at least half of the list's elements. Now here are your options for the answer. There's binary search, greedy, hash map, and brute force. Alright, so the answer is combining greedy and hash map, though hash map is kind of optional because the numbers are small enough to use an array. But you need a hash map or some sort of map to count the frequency of each element, and then you can just greedily remove the most frequent elements. Alright, question 12, here's the original question. And here's my short version. You're given 2 lists of strings A and B. The value of a pair of equal strings with one string at index x in list A and the other at index y in list B is x plus y. Your task is to find and list out all the pairs of equal strings with the smallest value. Feel free to pause. Now here are your options for the answer. There's hash map, 2 pointers, brute force, and dynamic programming. Again, feel free to pause. Alright, so the answer is either brute force or hash map will work here. For brute force, just iterate through each pair of strings, check if they're equal, and just maintain a list of the ones with the smallest values. For hash map, you can store for each unique string its smallest index in A and B, and that smallest index pair is the only valid one since any larger index would be larger. And that reduces the complexity to linear. Alright, question 13, here's the original question. And here's my short version. You're given a triangle of numbers. You start at the top and move down left or down right until you hit the bottom row. You want to find the path to the bottom with the smallest sum of numbers. Feel free to pause and think. Now here are your options for the answer. There's Dijkstra, BFS DFS, greedy, and dynamic programming. Again, feel free to pause. Alright, so the answer is either Dijkstra or dynamic programming. You can model this as a shortest path problem and run Dijkstra on it and it would work. But dynamic programming is similar and the state is just the cell and you would store the minimum total cost to get to each cell. And note that Dijkstra is basically just DP in a smart order, so these 2 solutions are almost equivalent anyway. Alright, question 14, here's the original question. And here's my short version. You have a group with numbers. At some time t, you can move between 2 cells if both of their values are less than or equal to t. Find out the minimum time t required to move from top left to bottom right. Now here are your options for the answer. There's greedy, DSU, disjoint set union, BFS DFS, and binary search. Alright, so the answer is either DSU alone or combining BFS DFS and binary search. If you want to use DSU, you can sort the cells and merge cells together until top left is connected to bottom right, then the value of t is the value of the previous cell you merged. And if you want the other solution, you can binary search in the value of t, and you can easily determine which cells you can move between, so you can use BFS or DFS to see if you can reach bottom right. Alright, question 15, here's the original question. And here's my short version. You're given a 2D grid of 1s and 0s where 1 is land and 0 is water. The land forms islands that are connected in the 4 cardinal directions, and your task is to find the size of the largest island. Now here are your options for the answer. There's BFS DFS, Dijkstra, minimum spanning tree, and dynamic programming. Alright, so the answer is BFS DFS. You should run a BFS or DFS for each island to find out its size by going through each node and take the largest. Alright, question 16. Here's the original question. And here's my short version. A number is self-dividing if it has no zeros and it's divisible by all of its digits. You're given a range between two numbers L and R. Find the number of self-dividing numbers between L and R inclusive. Now here are your options for the answer. There's brute force, binary search, dynamic programming, and 2 pointers. Alright, so the answer is either brute force or dynamic programming. Brute force is the most straightforward approach because L and R is small enough to just iterate through each number and check if it's self-dividing or not. But you can also do this with digit DP, where the state is the digits you have and the remainder mod the LCM of 1 to 9. And this would work for much larger L and R, but it's probably slower than brute force for these specific constraints. Alright, question 17. Here's the original question. And here's my short version. You're given a directed weighted graph. A message can go along an edge with weight x in x seconds. A message will be sent from some starting node k, and you should figure out how long it will take for every node to receive the message. If some node can't receive the message, the answer is just -1. Now here are your options for the answer. There's greedy, Dijkstra, DSU, and BFS or DFS. Alright, so the answer is Dijkstra, and this is pretty straightforward. The time for a node to receive the message is just the shortest path from the start node to that node. So run Dijkstra from the starting node and just output the shortest paths. Alright, question 18. Here's the original question. And here's my short version. You're given a tree that has one extra edge. Find the extra edge and remove it. Now, here are your options for the answer. There's BFS DFS, DSU, Dijkstra, and Kruskals or Prims, minimum spanning tree. Alright, so the answer is BFS DFS or DSU. Notice that in a tree, there's exactly one path between every pair of nodes. If there's more than one path, then that's the cycle you're looking for. So add the edges one by one until you encounter an edge where you already have a path between the two incident nodes, and that's the extra edge. Alright, question 19. Here's the original question. And here's my short version. You're given a 2D grid of letters. You want to remove some of the columns so that each individual row is sorted alphabetically, and you want to remove as few columns as possible. Return the number of columns you need to remove. Now here are your options for the answer. There's greedy, brute force, dynamic programming, and 2 pointers. Alright, so the answer is dynamic programming. Notice that removing the fewest columns is equivalent to keeping the most columns. And now this is very similar to longest increasing subsequence, except there are multiple layers. So do DP, where the state is the previous column you kept, and you store the maximum number of columns you can keep, with that column being the rightmost one. Transitions are just iterating through whatever you want the previous column to be. Alright, question 20. Here's the original question. And here's my short version. You're given an array. In 1 second, you can jump either left, right, or to another element with the same value as your current value. Find the minimum time to get from left to right. Now here are your options for the answer. There's greedy, dynamic programming, BFS, or Dijkstra. Alright, so the answer is either BFS or Dijkstra. And that part is probably clear, but what may not be clear is how to use them. And probably the most clean way to create the graph is to create a virtual node for each value. Then to simulate jumping to another element with the same value, you can jump to the virtual node and then to another node with the same value. And for this, you can add a directed edge from each node to its virtual node with weight 1, and then a directed edge from each virtual node to its nodes with weight 0. Then you can run either 0-1 BFS or normal Dijkstra. Note that the solution also involves a hash map, but you can probably do it without one, so you can give yourself the point either way if you got everything else. Alright, question 21. Here's the original question. And here's my short version. You're given an array of people, each one having a value. A team of 3 people, I, J, and K is valid if either AI is less than AJ is less than AK, or AI is greater than AJ is greater than AK. Count the amount of valid teams. Now here are your options for the answer. There's brute force, dynamic programming, Fenwick or segment tree, and binary search. Alright, so the answer is everything but binary search, actually. To do brute force, you have to be a bit smart. You can't just iterate over triplets, that's too slow. But if you iterate over the middle element, then you can notice that you just need to multiply the number of smaller elements on the left by the number of larger elements on the right, and vice versa. So you just need to count the number of smaller and larger elements on the left and right to each element. And you can speed this up easily with a FEMWaker segment tree as well. And as for DP, notice that if you had teams of size k, you can store a DP where the state is the previous person on the team and the number of people on the team, and it's very similar to longest increasing or decreasing subsequence. Here we only have teams of size 3, so it just works even easier. And you can also speed up that DP with the FEMWaker or segment tree. Alright, question 22, here's the original question. And here's my short version. You're given a grid of land and water. You want to assign heights to the land cells so that every adjacent pair of cells are no more than 1 apart in height, and water cells have height 0. You want to maximize the height of the highest cell. Now here are your options for the answer. There's Dijkstra, BFS, binary search, and DSU. Alright, so the answer is either Dijkstra or BFS. Note that every cell adjacent to a water cell must be height at most 1, and then every cell adjacent to a 1 must be height at most 2, etc. And in general, a cell's maximum height is its shortest distance to a water cell. It can be proven that this is optimal, and it's always possible to assign heights this way. It's very similar to DFS, or the proof for BFS. So for each cell, you just need its shortest path to a water cell, which can be done with multi-source BFS or Dijkstra. Alright, question 23. Here's the original question. And here's my short version. You have some infinite number of lakes. On each day, one of two things will happen. Either one lake will be filled with water, or you get the ability to dry out a lake and remove its water. If an already filled lake is filled again, it floods and you lose. You want to determine if it's possible to prevent a flood. Now here are your options for the answer. There's dynamic programming, hash map, ordered set, and greedy. Alright, so the answer is a combination of hash map, ordered set, and greedy. Here's the idea, or something else, but here's the idea. When you get the ability to dry a lake, don't use it immediately because you don't immediately know what lake you should use it on. Instead, you can wait until you need it, and when some lake is about to flood, you can go back in time, dry out the lake, and then prevent that lake from flooding. But note that you can't dry a lake if it was filled after you got the ability to dry, so you have to use a set to find the earliest dry that happened after the lake was filled, and the hash map comes from storing the previous time that the current lake was filled. And there's probably another algorithm that involves greedy and priority queue to immediately find the lake you should dry, so you can count that if you thought of it, but I haven't tested it, so I'm not sure. Alright, question 24, here's the original question. And here's my short version. You're given a binary tree and a value x. Your task is, while there's a leaf with value x, remove it. And note that removing the leaf may also create more leaves, which you should also remove if appropriate. Now here are your options for the answer. There's greedy, BFS DFS, Dijkstra, and brute force. Alright, so the answer is BFS DFS, and you can optionally count greedy as well. For this one, you just need to do what it tells you. DFS is probably better, but it's also possible with BFS if you're smart about it and do it backwards. So run DFS, and when you get to a node that's a parent of a leaf that should be removed, remove that child for the parent, and do that for every node. And note that DFS will process nodes from the bottom up, which is exactly what you want. You want to process the leaves first. Question 25, here we go. Here's the original question. And here's my short version. You're given a circular pizza with 3 end slices. In one move, you can take a slice, and when you do, one of your friends will take a slice in the clockwise direction, and another friend will take a slice in the counterclockwise direction. You want to take your slices to maximize the sum of sizes of the slices you took. Now here are your options for the answer. There's greedy, dynamic programming, brute force, and 2 pointers. Alright, so the answer is dynamic programming, but the reason why is probably not obvious. I will say this question is pretty hard, and that's why I chose it for last. The main observation is, as long as your chosen slices are never adjacent in the original pizza, there's always a possible order that will give you exactly the slices you want. So all you have to do for the DP is make sure you don't choose 2 adjacent slices, meaning that your state for the DP can be your position, the number of slices taken, and whether you took the previous slice or not. I'll probably post a proof of this somewhere else, but not here, it's too long for this video. Okay, now that we're done, let's take a look at what happened here. With high probability, there was at least one question where you had no idea where to begin, but then you saw the multiple choice and figured it out relatively quickly. If not, sorry. But if so, you can then argue that you wouldn't have solved the question without the hint from the multiple choice. But what if you can? What if you can create your own multiple choice? What if when you're totally stuck on a question, you just iterated through the stuff you knew and applied the same sort of process of elimination to see what would work or not? Because when you're stuck, it's likely for one of 2 reasons. Either you don't know the required topic, or you do know the topic but you're just not thinking of it. For the first reason, you just need to study more. I can't really help you with that. But for the second reason, you can try to apply each topic you know to the question and see if any of them work. This is typically called trying to force a specific topic, and it can be pretty dangerous if you rely on it too much, but as a last resort when you're stuck, it can get you out of a bad situation, and it's worked for me before. So if you get nothing else out of this video, at least you know now of this strategy. But this should also help you with like pattern recognition and stuff like that, so it shouldn't be all that you get out of this video. And you may also notice that I didn't include many data structure questions. This is because it's usually the case that the data structures themselves aren't really interesting. It's all about how you use them. So including them in a video like this wouldn't really do the questions justice. But I may do more of them in the future, we'll see about that. And beyond that, how did you do? And what did you think of the video? This is a totally new type of style for me, and I think it should do pretty well since giving the viewers something to actually do instead of just staring at me might do wonders for the watch time. But I guess we'll see. More of this type of video to come if this one does well, and some other stuff to come if it doesn't do well. Hope you enjoyed and or hopeful is helpful. That's all. Goodbye.